Hello there. We're looking at 229 through 231, I think. 229 through 231. Alright, so these are kind of fun. I like factor trees. So what you are trying to do is find the number of factors and break down the factors until you get to all prime factors. So start with something that you know for sure. I know that 6 times 6 is 36. I also know that 2 times 3 is 6, and so 6 is composite, so it can be broken down again. 2 and 3, 2 and 3. 2 is a prime number, and so is 3. 2 is prime because it has only 2 factors, and 3 is prime because it has only 2 factors. So the prime factorization of 36 is 2 times 2 times 3 times 3. And you'll notice how we put that in order from smallest numbers first, and then going in increasing order. Okay, the prime factorization for 50. Start with the factor tree. Start with something that you know. I like to keep it simple, 5 and 10. 5 is a prime number. 10 is composite. Okay, so the prime factorization for 50 is 2 times 5 times 5. Prime factorization for 100, do a factor tree. 10 and 10. 2 and 5, those are both prime. 2 and 5, again, those are both prime. So the prime factorization for 100 is 2 times 2 times 5 times 5. By the way, another way you could look at that is 2 squared times 5 squared. This number right here, the little number, is called the exponent. And it tells you how many times that the base is multiplied by itself. So 5 is the base, and it's being multiplied by itself twice. Next page. Yep, so we're looking at 11. So let's work this page too. This is also lesson 11. Tell whether the given numbers are divisible by 2, 5, and 10. Write an X in the table to show that the given number is divisible by 2, 5, and or 10. The table is completed for the first number, then complete problems 1 through 3. So ten is divisible by all of those. 12 is divisible by 2. It is not divisible by 5, not divisible by 10. 15 is not divisible by 2, but it is by 5. 27 is not divisible by 2, 5, or 10. 65 is not divisible by 2, but it is divisible by 5. 150 is divisible by 2, 5, and 10. Give an example of a 5-digit number that is divisible by 2. 1, 2, 3, 4, 6. So it's divisible by 2 because it is even. $12,346. Give an example of a 5-digit number that is divisible by 5. 1, 2, 3, 4, 5. It is divisible by 5 because it ends in 5. Give an example of a 5-digit number that is divisible by 10. 1, 2, 3, 4, 0. It is divisible by 10 because it ends in 0. Okay, I believe this page is the last page for 11. Let's double check. Yep, so this is our last page for today. Look closely at the table and answer the questions. So it looks like a lot right now. Whole lot of numbers, but let's make it a little bit easier to look at here. So there's a rectangle, 10 different rectangles, and they're starting with rectangles with a base of 19 and a height of 1. So the first rectangle looks something like this. Let's see, let's get some. The first rectangle had a base of 19 and a height of 1. So it was very long and not high at all. I don't know if that's 19. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So this is rectangle number 1. Okay, so look back at rectangle 2. Rectangle 2 has a base of 18 and a height of 2. If you'll notice, the perimeter is always the same here. So 18 and 2 is going to look like this. It has the same distance, it has the same perimeter, this is number 2, as number 1, but it has more area. So if you look at the table right here, you can see that the area of rectangle 1 is small, and the area of rectangle 2 is larger. So let's draw rectangle 3. It's 17 by 3. So here's 17 and there's 3. So you can tell that it's getting larger and larger. I think the pattern continues. 16 and 4, yes, so here's 16 by 4. Again, the distance around the outside is called the perimeter, and the perimeter for all of these is the same. The next rectangle. As you continue on down, you see that eventually they get to 10 by 10. And when you get to 10 by 10, you get the largest number of area for the same amount of perimeter. It's like a fence. If you were building a fence, you would get the most area enclosed inside if you did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This rectangle would give you the largest area, and it would have the same perimeter as the other ones. So what happens to the area when the difference between the base and the height gets smaller? If you look at the first example, rectangle number 1 has a large difference. 19 minus 1 is 18. So when the difference gets smaller, as they're showing here, as they continue down, the smaller the difference means a larger area. Okay, so what about, of all the rectangles, what shape has the greatest area? Well, we talked about that one already. It's going to be the 10 by 10 rectangle. I hope you're well. Thanks for watching. Please give me a call. 892. Oops, that's not very good. 29498. Thank you.